Hi, everybody. This is Mr. Martinez. I'm going to go over the geometric probability homework. Number 1 through 4, here are the directions. Point T is on segment AD, chosen at random. What is the probability that point T lies on the given segment? So I highlighted point T in blue. So the probability that the point is on segment AB, well, remember, probability is always a fraction. And probability on the numerator is the number of events that T would be on segment AB. So what we need to do is we need to measure how long AB is. So AB is 1, 2, 3, 4. There are 4 spaces where T can land on segment AB. Okay, so what we need to show is, well, the length of this segment is 4. So we're going to write 4. And then on the denominator, we need to write the length of the whole segment. And the length of the whole segment is from 3 all the way to 10. So you include the starting point. So that's 1, 2, 3, 4, 5, 6, 7, 8. 8. Okay, so we have 4 out of 8. Now remember, probability is a fraction or a number between 0 and 1. So this is a half, which is 0.5. Okay, so half or 50% or 0.5. I'm going to leave it as 0.5, but it's the same thing as 50%. Okay, so what that's saying is that we have half of a chance that it will land on AB on this segment here. Okay, so 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's go ahead and continue. Segment AC. So what is the probability that point T will land on segment AC? Well, let's measure the length of A to C. So 1, 2, 3, 4, 5, 6, 7. 7 here. So we have 7. We have a lot more numbers or length that a higher chance of it landing on that segment or being selected at front, and it's at that segment. So 7 over the length of the whole segment, which is 8. Okay, so if you want to turn this into a decimal so that we can understand 7 over 8, what that is, you can always use decimals. So 7 divided by 8, that gives you 0.875 or 87.5%. Okay, number 3, we're moving a little bit quickly here. BD. So B all the way to D. Let's see, 1, 2, 3, 4, 5. So that's going to be 5 over 8. And of course, you can look at the decimal form of that on decimals, but I'm just going to leave it as a fraction. All right, the last one, BC, the probability that point T is on BC. So BC is 1, 2, 3, 4. 4 over 8. And that's, again, a half. And we are done with this one. Pretty straightforward. Next one, number 7. Your class needs to find the probability that a point A is in the square chosen at random, lies in the shaded region. So what it's asking for is, what is the probability that a point is in the shaded orange region versus being in the semicircle here, in the white semicircle, or this other semicircle? Your classmate's work is shown below. What is the error? Please explain. Okay, so let's see what the error is, okay? So the probability that point A is in the shaded region, so the classmate, we'll call him Niall, is, let's see what Niall did. So area of semicircles. Okay, so that's pretty good. We do want to find the area of the semicircles at some point, divided by the area of the square. So it's asking us to find the probability that point A is in the shaded region. So if we put the area of semicircles, we are saying what's the probability that the point will be in the shaded semicircle? So Niall, you are in denial. Okay. We do not want to use just the area of semicircles. We will use it, but we need to edit this. Okay. So let's go over what the correct work should be. So the probability of A in the shaded region equals, what we are going to do is, because we just want to know the shaded region, we need to find the area of the square. Okay, so the area of a square is side times side, which is 64 units or centimeters squared. 64 centimeters squared. That's the area of the square. And that's going to be in the numerator. But we are going to subtract it. We're going to subtract it by the area of the square, of the semicircle. So I'm going to go ahead and, color code this as blue, just so that we know that that will be the area of the semicircles. Okay, so from here to here, that's the radius. And then from here to here, that's also the radius. So we actually just have a circle in here, a circle with a diameter of 8, or we have two semicircles that are both congruent. And so the radius, I'm going to go ahead and remove the blue just so it does not confuse you. So if we think about it separately, the radius is 4 because it's half of the diameter, right? Half of the square. And then the radius from here to here is also 4. So what we have is two semicircles that are both congruent. So we can just think of it as a circle with a diameter of 8. Okay, so it's almost like if we were to put the circle, complete the whole circle, and it was just like that. And it was just a circle instead of the square, just like this, and then the diameter would be 8. Okay, same exact thing, but we're just going to keep it different. So what we need to do is we need to find the area. Let's go ahead and find the area of this one. So the area for a circle is pi r squared. So it's going to be 16, right? R squared is 4 times 4, so 16 pi centimeters squared. But because it's a semicircle, we need to divide it by 2. So the area of this semicircle is 8 pi centimeters squared. Okay, so it is again, semicircle. So guess what? Because these two semicircles are also, they're congruent. And think about what makes circles congruent. What makes circles congruent is the fact that they have the same radii. So since they're both have the same radii, they're both congruent circles. So this area is also 8 pi. Okay, so what we need to do is we need to take the area of the square, which we got 64, and subtract it by the area of the two semicircles. So the area of the two semicircles is what Niall, right? Niall put 16 pi. He got that correct. But he forgot to subtract the area of the square and the area of the two semicircles. Okay, centimeters squared. And then, all right, Niall, hopefully that helps you out. Okay, and then because it's probability, we want to divide it by the area of the whole region, which is the square. So we're going to go ahead and put the denominator as 64 centimeters squared. Okay. What we want to do for the percentage or the decimal is use decimals. So we're going to do 64 minus 16 pi. And the whole quantity, this difference, so I'm going to put parentheses, is divided by 64. Okay. So the probability that point A is in the orange shaded region is 0.214. So I'm going to go ahead and write that down as a percentage. So I'm going to put in orange just because, the shaded region is in orange. So the probability is 21 I'm going to go ahead and round up because this is bigger than 5, so this is going to be 21.5%. So, if you're playing this at a carnival, you don't have, just based on mathematics, you don't have a super high probability. So just something to keep in mind, if you were ever to play something like this at a carnival game, you would have a higher chance of losing if it was just based on math and removing all other factors like your accuracy, wind, the type of dart or arrow that you would be throwing. Okay, next question. All right, so Niall, hopefully you understand now what your mistake is. 17. A point in the figure is chosen at random. Find the probability that the point lies in the shaded region. So this is the shaded region right here. And what we have is we have a sector that is shaded. So what we want to do is we want to find the area of the sector. So I'm going to go ahead and label it like this, almost like a sector notation. So the area of the sector, hopefully you remember what the area of the sector is. Feel free to pause. All right, the area of the sector is pi r squared, and r is 3, so that's 9. 3 times 3 is 9, times the ratio or the fraction of the sector. So since this arc is 80, we know that this central angle is also 80 degrees. So this angle right here is 80 degrees. So we're going to do 80. Here's the ratio, 80 divided by 360. 360. Hopefully you did not forget that. Okay, 360. All right, I'm going to also put this in over 1. Okay, so this is going to give us the area of the the area of the sector. I'm going to turn this into black because that's really the area of the whole circle. And then we're just multiplying it by this ratio, which is the ratio of the sector. Okay, so let's do a little bit of algebra. We can divide by 10, so the zeros become 1. So essentially this is 8 divided by 36. And then we can, since we're multiplying, we can divide 9 and 6. So these both have a factor of 9, I should say. So 9 divided by 9 becomes 1. And then 36 divided by 9 becomes 4. All right. And then one last thing, 8 divided by 4, that's just 2. So we did a lot of simplification. So now we multiply horizontally. 8 pi times 1 times 2, that is just going to be 2 pi. 1 times 1 times 1. So that's just going to be 2 pi over 1, which is just 2 pi. So here's the area of the sector, 2 pi inches squared. All right. And now since it's probability, right? We want to make sure that it's a fraction. So the numerator is going to be 2 pi, but we need to figure out what the denominator is. Now the denominator is the area of the whole region, and the whole region is a circle. And if you look above, we actually found the area of the circle. The area of the circle is this part right here, the one in black, pi r squared. So we know that the area of the circle is 9 pi inches squared. Okay, so 9 pi inches squared. All right, let's do a little bit of algebra. We can divide pi by pi. That becomes a 1. We can divide inches squared by inches squared, and that becomes a 1. Okay, so right now we have 2 times 1 times 1, and then we have 9 times 1 times 1. So essentially the probability is 2 over 9, and we can use decimals to help us out, or if you have a calculator. So the probability is going to be the following: 2 divided by 9. So that's 22.2 repeating 2 percentage. So pretty small percentage. Again, if you're playing this, your odds are not that good, just using math. Okay, So 22.2%. Next one, 18. A point in the figure is chosen at random. Find the probability that the point lies in the shaded region. So we want to find the probability that the point is in the outer ring. So take a moment to think about it. Think about what you are going to do. All right, here's what we're going to do. We're going to find the area of the small, I'm going to put S small square. Okay, and the area of the small square. And we know it's a square because it has all four sides congruent and four right angles. That is what a square is. So 9 times 9, that's just 9 meters squared. And then we're going to find the area of the large square, the area of the large square. Area of large, I'm going to use L square. All right, so for the area again, it's 5 times 5, which is 25 meters squared. And this is why we were practicing writing units squared, so that when we have units, like meters are units, we can remember to put meters squared. Okay, we're not done though. Remember, probability is a fraction. So probability, so on the numerator, we want to know the chances of the event occurring. And the event is that the point is in the blue ring as opposed to the whole square or the white square. Okay, so what we're going to do is we're going to take the area of the we're going to take the area of the large square, and then we are going to subtract it by the area of the white, because if we have the area of the blue, let me see if I can move this. If we have the area of the blue, that's what we have. Okay, and then if we subtract the area of the white, then we're left with the ring. So hopefully you can visually see why we are subtracting, because it's almost like we have a square in front of us that's colored in blue, and then I asked you to cut the inside squared with scissors. So we are removing that inside square. So minus 9m squared. Remember, we have to divide by the whole, we have to divide by the region, the whole region. And that whole region is the area of the blue square. All right, so let's see. We can take that into decimals. Remember, we cannot, if you're doing it in your head, we cannot divide the 25s, because right now 25 is being subtracted by 9. So if you think about the opposite of subtraction is addition, and this is not right here, this black bar is not addition, it's division. Okay, so that's why you cannot divide by 25 yet. All right, so let's see, 25 minus 9 divided by 25. Notice how the units go away. They go away because m squared divided by m squared is just 1. 25. So 64.64. So 64%. So this has a probability of 64%. So you're at a higher chance of hitting that target essentially. All right, next one. 19. A point in the figure is chosen at random. Find the probability that the point lies in the shaded region. So again, similar thing. We want to find the probability of landing or selecting the point on the shaded ring, the outer ring. So we are going to find the area of the blue circle, and that's going to be, the whole diameter is 6. So the radius is half, which is 3. So the area is 9 pi feet squared. And then we are going to do the same thing for the white circle, which I'm going to do in black. So the whole diameter is 4. So the radius is half, which is 2. So the area of the white circle is 2 times 2, which is 4 pi feet squared. Okay, so notice how even though the area and the diameter are the same, I didn't say that the area was 4 because the diameter is 4. I still divided this by 2, and then I squared it because the area of a circle is pi r squared. All right, last step is to find the probability. So the probability is, again, think about what we're going to do. We want to know the probability of selecting the point in the outer ring. So we're going to do the whole circle, the area of the whole circle. And again, it's almost like I did in the other one. You have the area of the whole circle, right? And then I ask you to cut out the inside circle. So that's how you get the area of the ring. So we're going to take the area of the outer circle and we're going to subtract them. Okay, so 4 pi, and then we're going to divide by the area of the total region, the bounded region, and the bounded region is the area of the whole circle, of the blue circle, I should say. All right, go ahead and feel free to do this in your head. 9 pi minus 4 pi, that is 5 pi. 5 pi over 9 pi, the pi's go away, and you're just left with 5 over 9. So 55.5555% chance. All right, that's how you do this one. Last one, a point in the region is chosen at random. Find the probability that the point lies in the shaded region. All right, let's go ahead and find the area of one circle. And they are all congruent, and we'll go over why in a bit. Let's first start off by finding the radius. So the radius is, or the diameter, I should say. So the diameter, right, goes through the center. So notice how one diameter is half of the square. Same thing here. So now what we have are 2 diameter. The first diameter for the first circle, and then the same length of the diameter. So this diameter is 6. Okay, so this is 6. In fact, they're all 6. That's how we know that these circles are congruent, because they are all 6. Since this right here is touching the square once, which is a tangent point, and then this, they're only these 2 circles are only crossing each other once, so that's a tangent point. And then again here, okay, so that's how you, and if we were to draw these diameters going vertically, it would be the same. So essentially we have 4 congruent circles. But I'm just going to find the area of one circle. So the area of one circle is not 6 squared pi, okay, because r is not 6. Radius is not 6. That's the diameter. So you need to divide by 2. So the radius is 3. So we're going to have 3 times 3, which is 9 pi. So that is the area of one circle, inches squared. However, we already went over that we have 4 congruent circles. So we are going to do the area of 4 circles. And guess what? All we do is we take the area of one circle and multiply by 4. So 4 times 9 is 36. So the area of all 4 circles combined is 36 pi. Don't forget about pi, inches squared. Okay. And then what we need to do is the last part is find the area of the square. So the area of the square is 12 times 12, right? Side times side, or base times height, which is 144 units squared. All right, so take a moment to think about what the fraction is going to be. All right, here's what the fraction is going to be. So the fraction is the area of the blue shaded region. That's the denominator, that's it. There's no subtraction going on here. And I'll go over why in a bit. No subtraction. Divided by the area of the whole region, And that's it. Now let's go over why there's no subtraction. Okay, so notice here how the shaded region are these circles. Notice here how the shaded region is just the ring. Just the ring. Same thing here. Notice how the shaded region is just this outer perimeter or ring, I should say. That is why in these two, in number 18 and 19, we subtract for the numerator because we are removing a part from the inside. Notice the difference in the last one. Here, we are not removing these circles. We are not removing those circles. So that is why we do not subtract because we want to know the area of the blue shaded region. Now, if the shaded region were the white spaces, let's say the shaded region were the ones in white, then we would subtract. Then it would be the area of the square minus the area of the blue circles. That would give us the white regions, but it's not asking for that. Okay, so last part, let's go ahead and put this in a calculator. 36, don't forget about pi. I'm using pi, I'm not approximating, divided by 144. All right, so the probability is 0.785 or 78.5%. All right, everybody, have a great rest of your day. Take care.